sines. Okay, first of all, law of sines, you have to memorize this formula. It basically says sine of angle A is proportional to side A is the same thing as sine of angle B that is proportional to side B, and is equivalent to sine of angle C proportional to side C in any given triangle A, B, C. Notice this is side B, this is side A, and that's side C, and this is angle C. Now, in our assignment, sometimes they use the Greek letter that's your C, and this really means alpha if you want to change that, and they'll use this for B. So if you want to change this into, A, B, and C, so you can do that. Alright, so you have to memorize this theorem right here, or this law. This is known as law of sines. This works for all triangles, okay? But so far we've only been dealing with right triangles, okay? But not all triangles are right triangles, so we have to come up with a different way to solve for non-right triangles. This is a law of sines. So instead of proving this theorem, let's just get to it, and this isn't that bad. The first part is easy, okay? The second part gets a little bit more complicated. So let me clear this real quick here. Okay, this is section 39, and let's start with problem 2. It says angle A is equal to 70 degrees, and then it says angle B is equal to 60 degrees, and they tell you side C is equal to 4, and they want you to find all the angles, okay, and the sides of a triangle. So let's draw a random triangle, okay, and let's call this angle A, call this angle B, call this angle C. So we know this is to be 70 degrees, we know that to be 60 degrees, so 70 plus 60 is going to give me 150, so that has to be 30 degrees, and we know this is 4. Okay, law of sine says I can use this formula. Sine of angle A is to side A, and that is the same thing as sine of angle B is to side B, and then the same thing as sine of angle C is to side C. Okay, so which one of these three do I use? Well, first of all, I have to know a side. So I know side C, so that means I'm going to use that. Okay, sine of angle C, which is 30 degrees, is to side 4. Okay, so I know angle C, I know side C, so I have to use that. So now, which side do you want to find? Do you want to find side A, side B? It's not really important. You can find either one. So let's go ahead and find side B. So I'm going to use sine of angle B. Oops, sorry, getting ahead of myself. So sine of angle B, which happens to be 60. So that's 60 degrees, is to side B. Okay, then we go to our unit circle. Well, actually you can go to unit circle because 30 and 60 are part of the unit circle, but we're going to go to our calculator, so we can use calculator from this point on. Notice this is in degrees, so I have to change my calculator to degrees. I'm going to do that. Okay, I'm going to go to degrees. Okay, now I've converted my calculator to degrees. Okay, we're going to find sine of 30 degrees. So sine of 30 degrees, close my parentheses, hit enter. Okay, and that's 1/2. Yeah, which is also 0.5. So let's convert that to decimal, 0.5. And then we're going to divide that by 4. Okay, and that's 0.125. So this side turns into 0.125, and that's equal to sine of B. So let's go find sine of B, which is 60 degrees. Okay, see if I can do without parentheses, or it will give me an error. Yep, just as I thought, an error. Let me put parentheses. Okay, hit enter. Okay, and I don't like that, I need decimal. So, and that turns out to be 0.867 is to b. Okay, I have to solve for b, so I can just cross multiply. Okay, so if I just cross multiply, this is really a 1 underneath the 0.125, so that's 1. So when I cross multiply here and here, or they end up switching. So when I cross multiply, these things end up switching. So this really means b is to 0.867 divided by 0.125. Okay, so we're going to divide that by 0.125, hit enter, and that turns out to be approximately 6.928. Okay, so this side right here is 6.928. Okay, so the only thing that's left for me to find is side A, so I can use that formula right there. Since I already know this, sine of 30 degrees over 4 is 0.125, so might as well go ahead and use that. So sine of 30 degrees is to 4 is to sine of angle A, which is 70, is to side A, and this is 0.125. And then let's go find sine of 70. So sine of 70 degrees. Okay, close the parentheses, hit enter. Okay. Alright, I need to change this into a decimal. Keep forgetting to do that. That'll be point. Okay, it turns out to be 0.940 is to A. Of course, to solve A, we're going to just cross multiply everything. So my A will turn out to be 0.940 divided by 0.125. So let's divide that by 0.125. Hit enter, and that'll give me 7. Okay, A turns out to be 7.518. So this side is 7.518. And that's it. Okay, that's all it is. It's real easy, except when we get to more difficult one in a second. So there's only 3 examples I need to do for you, okay, today. So it shouldn't be that long. So let's jump to problem number 4 as an example. And let's say angle A is 110 degrees. And they tell us angle C is 30 degrees. And then they tell us side C is 3. Okay. And if we get degrees, we're going to round off to a whole number. Alright, so draw a random triangle. It's not drawn to scale, so don't panic. A, B, C. This is 110 degrees. And this is 30 degrees. And this is side C, which is 3. And side A and side B are located there. Okay. So, since I know side C, I'm going to use sine of angle C is to side C. And I can find side A because I know angle A, so sine of angle A is to side A. Now I know actually angle B also, but sine of C means sine of 30 degrees is to side C, which is 3, and that's equal to sine of angle A, which is 110 degrees, is to side A. Okay? Alright, so we're going to now figure out what that is, and that's 0.5. Sine of 30 degrees is 1/2, so it's 0.5 over 3 is equal to sine of 110 degrees. Sine of 110 degrees turns out to be 0.3 or 940. All that is to A. Okay, when I divide 0.5 by 3, this turns out to be 0.167. and that's equal to 0.940 is to A. Then I'm going to cross multiply to solve for A. My A is 0.940 over 0.167, and when I do that, that turns out to be approximately 5.629. So I know my A, and that's 5.629. Okay, the only thing that's left for me to do is find out what B is, and since I already know that ratio, I'm going to use the same thing, so I don't have to recalculate that. Sine of 30 degrees is to 3 is to sine, what about my angle B? I can't find side B until I know angle B, but that's not hard because this is 30 and this is 110. That's a total of 140, so this has to be 40 degrees. So sine of 40 degrees is to side B. Okay, from the last part, this, when we calculate that, that turns out to be a 0.167. So I don't have to recalculate that, but I do have to calculate what sine of 40 degrees is. So I'm going to go to my calculator, type in sine of 40, okay, and I'm going to make sure I get a decimal answer, which is 0.643, all that it would be. So to find B, I just need to cross multiply. So my B is 0.643, all that over 0.167. So I'm going to divide my answer by 0.167, hit enter, okay, and that turns out to be approximately 3.849. 3.849, so this is 3.849. Okay, so we know all the angles and all the sides of a non-right triangle. Okay, there is one more situation, and this is known as an ambiguous case, and this is a hard one, so let's do number 12, and we'll talk about an ambiguous case. In this situation, I have angle, I have side A, not angle, so let's start with side A, which is 2, and I have side C, which is 1, and I have angle C, which is 25 degrees. Okay, so be careful how you draw the triangle in this one. Okay, what I'm going to do is I am going to put my angle right there. That's 25 degrees. I'm going to put that right there. Okay, as soon as I do that, this is my angle C. So my side C, okay, and that's my side C, and I'm going to call that 1. Okay, so the remaining side A, I want to put that here. And this is a reason. If you have an ambiguous case, actually you should do that all the time because you don't know when it is an ambiguous case. Okay, so that's side A, then this has got to be angle A, and that's got to be angle B. Okay, since I know angle side C and angle C, okay, since I know those two, so I'm going to go sine of C is to C, and since I know side A, therefore it's going to be sine of angle A is to side A, because I can't use angle B or side B. So that's my side B, and I have to find that, and angle B I have to find that, and angle A I have to find that because it's all missing. Okay, so we know that, so I'm going to write in sine of 25 degrees is to side C, which is 1, okay, and that's equal to sine of angle A, which I don't know what that is to 2. So we're going to punch in sine of 25 degrees, hit enter, and I need an approximation, and this turns out to be 0.423 divided by 1 is still the same, times sine of A, all that over 2. We're going to cross multiply that, so that means I'm going to multiply that by 2, okay, and that's going to give me 0.845, okay, is equal to sine of angle A, and of course we're going to take sine inverse. So to find A, we're going to take a sine inverse of 0.845. Okay, so let's go find sine inverse. Okay, so the green button, sine inverse of 0.845. Okay, and hit enter. And this turns out to be approximately, okay, let's round this to 58 degrees. Okay, this is 58 degrees. Remember, sine inverse only exists in the first and the fourth quadrant, and when we took sine inverse here, since this is positive, this is giving us an angle in the first quadrant. So you could have an angle in the second quadrant where sine is also positive. So we have to account for that. We'll do that in a second. This is why it's called an ambiguous case. Okay, while we're there, we might as well go ahead and find angle B now. Okay, so we're going to take 58 and add 25. Okay, and that's equal to 83. And we're going to subtract 180. Okay, and of course that gives 97. So that means angle B has to be 97 degrees. As soon as we know angle B, we can now, okay, find side B, and we can still use this right here. Sine C is to C. So sine of 25 degrees is to 1, is to sine of 97 degrees is to B. Okay, and then this we figured out the left hand side, that turned out to be 0.423 is to sine of 97. So let's go find sine of 97 degrees. Okay, and that turns out to be 0.993. Okay, 0.993 is to B. And of course B, we're just going to cross multiply. Be 0.993 divided by 0.423. So let's go ahead and divide that by 0.423. Okay, and then let's see what that turns out to be. And this turns out to be approximately 2.346. So that's my B, which is 2.346. Okay, everything looks good. Okay, so we can say, hey, we solved this triangle, but that's not the case. Now, we could have two triangles, and let me show you how you could have two triangles. If you were to take this side right here and rotate this, okay, so this falls over here, okay, now you have a triangle. This is still 1, and this is still 25 degrees, and this is still 2, so you could have that triangle. You don't know if you have that triangle or not, so you have to go and check if you have a triangle. Okay, so let's go ahead, put in, if we know that this side is same as, oops, let me get to that, and this side, and we found out this is to be 58 degrees. Okay, so since these are isosceles, this is an isosceles triangle here. Okay, that'll be 58 also. Okay, if that's 58 from geometry, you know that the angle to the left of that, okay, which is this angle, there's supplementary angles, so that'll be 180. Okay, 180 minus 58. Okay, and that's going to turn into 122 degrees. So that's 122 degrees. If that is 122 degrees and this is 25 degrees, and so you add 122 plus 25, okay, that turns out to be 147. So we can get another angle right here for angle B, and that angle right there, okay, is let's see, 25 to 120, 122 plus 147. So 147 minus 147 minus 180. Okay, so that angle has to be 33 degrees. So instead of 97, that could also be 33 degrees. That way we have two possible triangles, and this is known as ambiguous case. I'm sure you have questions for this type of problem in class. So we have to go find that too. Okay, so let's go ahead and find our values. Since we already know what sine of C and side C is, that ratio is same as that, which is same as that, we could use that. Okay, we could go ahead and use that to solve our problems. Okay, so I am solving for the smaller triangle now. Okay, and because there's a possibility I have two triangles in this, there are two triangles in this situation. So let's go ahead and solve for that. Let me cut out the stuff that I don't need real quick. Okay, and we'll get started on this. Okay, alright, so I know sine of C is the side C because I've calculated that, and now I'm going to find sine of 33 degrees is to side B. So this could be my different B, my second B. Okay, so sine of C is sine of 25 over 1 is to sine of 33 over B, and the left hand side, this turned out to be 0.423 is to sine of 33, and sine of 33, let's go ahead and calculate that. So let's go to our calculator. Sine of 33, close parentheses, okay, enter. That turns out to be a point, okay, 544. 0.544 is to B. Of course, to find my second B, I'm going to cross multiply 0.544 over 0.423. Okay, so let's divide that by 0.423. Okay, hit enter. Okay, and this turns out to be 1.288. So I have a small side B, which is 1.288. Okay, so I have one triangle. Let's figure out all the triangles here. I have one triangle where my angle A is 58 degrees, and side A is 2, and angle B is 97 degrees, and side B is 2.346, and angle C is 25 degrees, and side C is 1. I have that triangle. Okay, and I also found a second triangle where angle A, okay, now turned out to be 122 degrees, and side A turned out to be 2, and angle B, it turned out to be 33 degrees, and then side B turned out to be 1.258. Angle C is 25 degrees, and then side C turned out to be 1. Okay, so that's my second triangle. So I can have two possible